23-minute talks for full papers and 15-minute talks for short or notes papers. And each full paper is followed by a 7-minute question and answer session, while notes papers are followed by a 5-minute question and answer session. So to ask questions, please add your questions in the chat box, or after the talk is over in the question and answer session, please raise your hand to ask a question. If you have any difficulties with Zoom, please send us Zoom Masters a message. You can identify us through the names we have as Zoom Master in the prefix. So I'll probably go ahead and start recording the session now. I think it's already recording somehow. Yes, so it's recording now. And it's over to you, Julian.
Great. Okay, well, thanks a lot, Ram, and thanks, Daniela and Itamar. Yeah, so my name is Julian de Hoog. I'm an honorary research fellow at the University of Melbourne. I have the honor of chairing this session. We have 5 very interesting papers. I've had a look at them, some really interesting presentations to come. 3 of them are notes papers, 2 of them are full papers. And I believe the first 4 will be presented live, and the last one will be, we'll watch a recording because of the time difference. But without further ado, I'll pass straight to the first presenters, Zhuo and Wang. And I don't have a bio for you, so you'll have to introduce yourself. So please just a quick introduction of who you are, and look forward to hearing about your paper. Over to you. Who will be presenting? Is it Zhuo or Wang? I noticed you're both in the conference.
Yes, I'm Zhuo. Do I need to open the? I mean, to show me. Yeah, open the camera. I think I need that.
But in general,
this is what
it's nice, but
look like.
Great.
Sorry, I'm a student at Monash University, and Dr. Wang is my supervisor. We do this conference paper, and I will do the presentation. Can I start now?
Yeah, absolutely. Thanks very much. Please go ahead.
Okay. Share screen and. So I will start. Can I start? Right?
Yes, please. Thank you.
Okay. Here is the title of our paper, and I will. It's my great honor to do this presentation. And here is the outline of the presentation. Now let's start from the introduction. Currently, smart meter has been widely installed in households like this. These smart meters can collect smart data and send this data into utility office. This data contain users. Sorry about that. I'm sorry. We can see that smart meter data contain user load patterns, which can represent users' consumption behaviors. In other words, different social groups have different demands and daily activities, which can result in different load patterns. Here is the example. This data from what we used in our paper. For example, for this household, it has a couple of, it's a couple with elderly users, so the load pattern looks like this. And this one is a family with children. This child is under 12 years old. I will also mention this in the after parts about the insights. It's the load pattern. But now, the relationship between demographic and socioeconomic features and load patterns have not been well explored, which can lead to energy injustice. More specifically, and it's like the same energy policy affects users differently. such as it's unfair to vulnerable groups because vulnerable groups with inflexible load may be affected by higher electricity rate during peak hours. But if we can identify the relationship between demographic and socioeconomic features and load patterns, it can contribute to energy equity and justice. For example, the utility can make better policies and provide other benefits to the users according to their social, economic, and demographic features. Here are some related works. These works still have some knowledge gaps. The first one is this work directly using raw data for clustering. The noises and outliers will affect the results of clustering. And also for utility office, they always pay more attention on the overall trend of the load profiles rather than some subtle difference between load profiles. But directly using raw data cannot highlight the overall trend such as load shape and peaks. And also, this works just dividing users into clusters. This cannot capture the heterogeneity of load patterns. If I discuss it more specifically, it means most users cannot only fix the only one load pattern. A user might have more than one load patterns, but just segmenting users into clusters cannot capture this feature. But in our work, we can fill these gaps. That's our main contribution. We develop a framework to analyze the relationship between load patterns and demographic and socioeconomic features. Firstly, we need to reduce the effects of noises and highlight the overall trend of load data. So we use the symbolic aggregate approximation, which is SAX method. Secondly, we need to extract load patterns from load data. So we use the k-means method. Thirdly, we need to find a relationship between load patterns and demographic and socioeconomic factors. So we use the deep neural network, which is DNN. Finally, we need to validate our results. So we use some real-world data. Here is the data we use. We use data from the Pecan Street database. It's a database from North America. And we focus on load patterns on the group level, and all the data are anonymized, so there is no privacy issues. And our data can be divided into two parts. We can see this figure. There are two parts. The first one is load data. It's the electricity usage in kilowatt hour. It looks like this. And the other one is the demographic and socioeconomic data, which was age, income, education, and the household square footage, because they are the most relevant features. We can see the data looks like this. And firstly, because of the characteristic of smart meter data, it contains noises and outliers. And like I said before, load shapes are more important. We need to use SAX because this method can reduce the influence of noises and small variance, and also highlight the trend changing of load profiles. This picture shows the SAX-based load data processing. Firstly, we need to convert raw data into some segments. Looks like this. Use the average, and then we need to find the breakpoints. And allocate each segment into the closest breakpoints, then convert a time series load data into a string. In our work, we firstly converted the raw data into 8 segments, and then we find 5 breakpoints to convert the data into a string that contains 5 characters, which means 5 discrete values. In our paper, we call this SAX level. And then we need to extract the load patterns from the SAX processed load data. We consider both sum of the square errors and silhouette index to determine the value of K. And the best value is 7. And here is the result of clustering. Although the heterogeneity of users' load pattern use the distribution over 7 clusters. Here are the types of typical load patterns. The first one is single peak. Looks like this. There's only one peak indicating that energy intensive activities, while other lower energy consumption periods usually indicate that users are resting or not at home. And another important type is dual peak. Looks like this, cluster 1 and 2. And also we can this type means users have routine activities in the morning and in the evening. After we find the load patterns from the load data, we need to find the relationship between users' load patterns and their demographic and socioeconomic features. This problem is a regression problem, so we need to use a regression model. We use the demographic and socioeconomic features as the input and use the probability distribution of load pattern as the output. Because of the highly nonlinear relationship between the input and output, we use the DNN model. Here is the structure of our model. There are 3 hidden layers, and each layer has 100 neurons. And we also use linear regression model and polynomial regression model as benchmarks. Here is our results. The bar represents the probability distribution of load patterns. We can see that the model has a better fit than benchmarks. For this picture, it's about household 59. Their load pattern concentrated in cluster 4, which means the cluster 4 and cluster 2. Which means the daily activities are concentrated in the morning. And for this user, household 585 also concentrated in class 2 and class 4. But for household 121, the distribution of load pattern is less concentrated, and the cluster 6 has the highest. It has the biggest part. Which means the activity are more. And this household has more activity in the evening, because this cluster means the peak in the evening. The difference between these users can be because of their age. Both household 59 and 585 have the users are over 65 years old, but this household also has a child who is under 12 years old, and I also mentioned at the introduction part. I mean the demographic of the families. So we can find some insights. Firstly, elderly users usually stick to routine activities. They are also likely to wake up early and have hot breakfast that consumes more energy. And households with children have a peak during the evening hours, which can be caused by cooking dinner and some family entertainment activity with children. Households have peaks in the evening have a higher potential to contribute to demand response, but extra attention needs to be paid to vulnerable groups. In conclusion, we've firstly improved the casting results by using the SAX method to process the load data. Then we count the probability of users appearing in different clusters to capture the heterogeneity of load patterns. We also extracted the load patterns of users by casting and associated them with users' demographic and the socioeconomic features by DNA model to find a relationship. In addition, we find that elderly users have more regular routines and tend to wake up early, while families with children tend to have more activities in the evening. Our results can help improve the understanding of the different energy needs of different social groups. This means the promotion of energy equity and justice. In our future work, we plan to explore the impact of other factors and analyze the impact of the energy policy on users and energy equity. That's all about our work. We look forward to discussing it with you. Here is our contact information.
Great. Thank you very much, Zhuo. Very, very interesting. I hadn't actually, I've seen this sort of disaggregation before, but I hadn't thought about the equity implications and how pricing based on clustering could actually unfairly impact some groups. So really interesting. Are there any, so as a reminder to everyone, we can pose questions in the Zoom chat, but even better perhaps on Slack so that we can keep it afterwards. Are there any questions so far? Oh, Frederick from chat.
Hi, yeah, thanks for the very interesting talk. I just have a question for clarifying. You're talking about identifying usage behavior.
Yes.
I remember, I think in the Pekin Street data set, there are households with some technologies, right? Like rooftop solar or electric vehicles or so on. So I was just wondering if you might be detecting such technologies as well, or if you excluded these households altogether.
Sorry, I'm a little bit confused with the question.
Sorry, I'm Hao Wang. I'm Zhuo is like the supervisor, and Zhuo just started her MPhil this March or April. So this is her first presentation at the conference. A little bit nervous, I would say. Yeah, thanks for the question. To answer that, actually, we have another series of work on load disaggregation or energy disaggregation or kind of activity or appliances detection. I think for that, actually, we can kind of detect in real time, say which appliances or the certain energy activity, right, kind of happens there, and also we can also detect whether people possess like EVs or things like that for some various different applications like upselling and different provide services. So that is actually another line of work, and this one is more on the kind of explore the kind of diversity, right, in the people's load patterns and the implication, right, of the different social groups that may have different, will be impacted by the energy program, demand response, and tariff, all sort of things. That this actually open kind of opportunity to look at energy fairness and equity problems.
Great,
All right,
thank you.
thanks.
All right, we're running slightly over time. If there's a quick question, because we started a minute or two late, Michaela, if you want to ask a quick question, and then maybe we'll move the remaining questions to ask.
Yeah, sure. It's going to be a quick question. Just a curiosity. Maybe I missed this, and you mentioned, are you distinguishing weekdays from weekends? Or are you building patterns that takes into account that typically people have different behaviors in weekdays and weekends? Thanks.
Yes, according to our work, the activity and the load patterns are different in weekdays and weekends. But because of the space limited of the note paper, we only analyze the load pattern and activity in the weekdays for this paper.
Yeah, just to quickly add to it, Zhuo actually already finished a full-length paper on the kind of more comprehensive analysis with separate weekday and weekend to compare the load patterns on weekdays and weekends. So that is the answer, yes, and we've done that.
Thank you.
Yeah, thank you.
Great. All right, thanks. Any remaining questions, please post them in Slack. Thanks very much for the great presentation, Zhuo. That was very, very interesting.